Welcome back to Physics 30. This is the CO1 mechanical energy review. It's what you need to know for the upcoming exam. So of course the sections that we're looking at here, CO 1.1 through 1.7, work done by a constant force, work done by a varying force. We looked at kinetic energy and how that relates to work. We looked at potential energy, then relating 1.3 and 1.4 together for mechanical energy and its conservation, and then problems involving that. And then lastly, power. So if we look at what will be on the exam, part one will be multiple choice, 10 questions worth 10 marks. And of course, yes, it's an open book exam like the previous one. Short answer, there'll be 4 questions worth 25 marks, so a total of 35 marks, just like usual. To give you some hints, and also you'll have this sheet, a newer formula sheet that has the CO1 formulas embedded into our previous formulas that we looked at. So if we look at the bottom here, work is equal to the force that's parallel to D multiplied, and of course if we're pulling at an angle, it's the cos of the angle that it's being pulled at to give us the component that is parallel to D. If we're looking at a varying force versus displacement graph, of course it's the area under the curve, length times width if it's a rectangle, or half the base times the height if it's a triangle. And then we have our kinetic energy formula, gravitational potential energy formula. The change is going to be final minus initial for velocity if we're talking about kinetic energy, and then final minus initial height if we're talking about gravitational potential energy. And of course the work done is equal to the change in energy, whether it's kinetic, or change in energy, whether it's potential. And then these two can combine to give total mechanical energy, which is a combination of the two. And then we also had 2 work formulas here. If we know what the work done or change in energy, we can take that divided by the time in seconds. That gives us power. Or if we're exerting a force on something and it's undergoing a certain velocity, that's another way we can figure out power. And of course, going from horsepower to watts and vice versa, 1 horsepower equals 746 watts. So if we go back to the review, determine the work done on lifting something up when a constant force is applied. So of course that goes back into this idea, work is equal to force times displacement. And yes, if we're lifting something up, of course we're going against gravity. So if you can figure out Fg, you can analyze it vertically and get what that is. And if you look back in your notes, you should be able to find some examples in which we did that back in CO 1.1. Varying force, that's where we had the force versus displacement graph. So using the idea of work is equal to force times displacement. If it's a force versus displacement graph, of course the area under the line will give us the work involved. So if it's a rectangle or triangle, etc. So you can look back in your notes and find examples dealing with that. Determine the power in lifting something up. If you go through section 1.7, we did examples dealing with that. Again, you're exerting a force equal and opposite to Fg, and of course manipulating the work is equal to force times displacement. And then once we know what work is, divide it by time in seconds, and you should be able to easily get that. And then lastly, kind of similar to the roller coaster question that we had, involving something starting up really high, going low, changes in energy. So determining kinetic energy and gravitational potential energy of objects throughout, and then applying that to mechanical energy questions. So if you look specifically, 1.3 is kinetic energy, 1.4 is potential energy, and then 1.5 and 1.6, that's kind of where this question is leading to, looking at maybe calculating final velocity or height, etc. That's what that involves there. So the remaining marks, I think, fall into this. I didn't label it here, but whatever is left over here, so 15, so 10 marks here, I guess, would be included for this section here. Okay, so let's see, 10, 16, 25, yes, so 10 marks for that last question here. And of course, since this is an open book, no rewrites, because you are allowed to use your notes, etc. All right, we'll see you again.